Hi everyone. In the given problem statement, we have to find max points on a line. So we are going to given an array of points where point I is x and I represent a point on an xy plane and return the number of points that lie on the same straight line. So there are few things we need to understand, and it's a little bit of a more of a mathematical question than a coding problem. So right, if I have to find a straight line in an 2D plane, right? We are going to get it by the equation equal to y equal to mx plus b, where m is the slope which has been represented by, let's say I have 2 points, right? So f- points could be x0 and y0, and another point which is x1 and y1. So it can be represented by y1 minus y0 and x1 minus x0, and b out here, right, is going to be the intercept, which is going to be y0 minus m x0. There would be also certain edge cases or special cases, right? There could be a situation, right, where two vertical lines x1 could be equal to x0. In that case, right, according to math, it is undefined. So I can return here value of x0 comma none. Similarly, if y1 equal to y0, then it is a vertical line. Oh, sorry, it's an horizontal line. Horizontal line which is represented by 0 comma y0, and this is a vertical line. So that is the basic idea. So right, we are going to loop through, right? So we can create two loops. So the time complexity would be big O of n square. And here, right, we can take these 2 points. We are going to find the slope and the intercept. And based on that, right, we are going to store the values. So that is the idea how we are going to work it out. Now let us jump to the Python solution. The first thing that we are going to do, right, we are going to check if the length of the points given is 1. In that case, we are going to return 1 because only one value or the maximum points on a line can be 1. Once that is done, right, I'm going to create a for loop. So for I in range 0 to length of points, and I can just give -1, and for j in range I plus 1 to length of points. Once that is done, right, I have to find the values. So it would be like x0 and y0 is points of I, and x1 and y1 equal to points of j. Then we are going to calculate the line. So I'm going to call the function find line, and I'm going to pass in the value of x0, y1, y0, x1 and y1. Once that is done, right, I need to create the function. So the function would be def find line, and the values it's again x0, y0, x1 and y1. So now the first thing that we have to check for the cases. So if y0 is equal to y1, in that case it's an horizontal line, so you can return 0 and y0. If x0 equal to x1, return none and x0, it would be x0 and none. And else, right, we can calculate our slope. So slope value would be y1 minus y0 divided by x1 minus x0, and intercept is basically y0 minus slope into x0, and I can return the slope and intercept. So now we have created find the function of finding the slope and intercept, right? Now for two values or 2 points to be in the same line, right, I have to create some dictionary or a hash map that is going to calculate whether the two lines have the same slope or intercept. So for that, right, let me call a function. So from collections import default dict, and I can say lines equal to default dict, and I can pass in set. So in case, right, the same values are appearing twice, right, I just need to find the unique values. So that's the idea. And now what I can do, lines, and the value, right, the key would be the line of slope and intercept dot add my I point, and lines of line dot add my j points. Now I can return the maximum value, but before that, right, let me call or let me loop through the entire value. So for line in lines, and I can say length of lines of line, and out here, right, I have to just calculate the maximum value. So it would be max, and that should work. So I'm getting all the values for a slope and intercept, right? What is the length, and I can return it up. Let me click on run. The public test case is passed. Let me click on submit. As you could see, all the test cases passed, although it's giving a runtime of 36.56, so the time complexity will be big of n square. It can be further optimized by using some caching or some other mechanism, but the basic idea, right, of slope and intercept is the main building block of solving this problem, and I'm pretty sure you need to use it there. So if you have some other solution which would be much more better than big of n square, do let me know in the comments. That's all for this video. See you in the next one.